Welcome back. This is Mr. Hassan's Maths channel. I'm now answering a question from a Mechanics M1 paper from AQA, Examining Board. And this is from January 2010. It's a question that some students were having a bit of a debate about. And the question here is about a crate of mass 200 kilograms is initially at rest on a rough horizontal surface. A smooth ring is attached to the crate. A light inextensible rope is passed through the ring, and each end of the rope is attached to a tractor. The lower part of the rope is horizontal, and the upper part is at an angle of 20 degrees to the horizontal, as shown in this diagram here. It says when the tractor moves forward, the crate accelerates at 0.3 meters per second squared. The coefficient of friction between the crate and the surface is 0.4. Assume that the tension T newtons is the same in both parts of the rope. Draw and label a diagram to show forces acting on the crate. Okay, so here they've kind of like almost defeated the purpose of giving you a ring here, because the whole purpose of giving you a ring, they should have said a smooth ring. Did they say smooth ring? Okay, pass through the ring, a smooth ring, yeah. So, I mean, for if they really wanted to test you here, then they wouldn't have to mention that the tension is the same in both parts of the rope. That's the whole point of having a ring there. So a ring is such that when you have a rope that is kind of passing through that ring, then if the ring is smooth, there's no friction in it, then the tension in either side of that ring will be the same, just like a smooth pulley. Okay, so I don't know why they gave that away to make it a bit too easy, but no problem. Here we have to make a diagram to show the forces acting on the crate. So I'm going to draw a rectangle to represent the crate. Now, of course, this crate has its weight acting on it, which acts vertically downwards. Okay, and we know that the crate has a mass of 200 kilograms. Okay, as they told us. So the force acting on the crate is going. The weight is going to be 200 G newtons. All right, that's 200 G newtons. And when it's on contact with a surface, there will be a reaction force acting, which will be perpendicular to that surface. So the reaction force acting on the crate from the floor that is in contact with is going to be acting upwards. So I'll label that as R. And then you have the horizontal, the rope that's horizontal, and that there's a tension T in that rope. And then there's a rope which is 20 degrees to the horizontal, and the tension in there is exactly T newtons as well. And that's at an angle of 20 degrees to the horizontal. And then because it's a rough surface, there's a frictional force acting, which is acting in the opposite direction, okay, to the movement. Okay, and it's reached its maximum value, so it's F max, which you could say is mu times R. Okay, because it's moving, the maximum value of the friction has been reached. Okay, so that is a diagram to show the forces acting on the crate. Okay, now for part B, it says express the normal reaction between the surface and the crate in terms of T. Okay, now for this, just make a bit of space here. This is where there was a bit of a dispute between some of the students about how to do this. Okay, now what I would do if I wanted to talk about the reaction force and express the normal reaction force between the surface and the crate, I would resolve the forces vertically. Okay, and then I would say, okay, any force that's not vertical, we have to resolve it in the vertical direction. So let's take the tension and resolve this tension here vertically and horizontally, right? So vertically, this you have to move, or if I want to resolve this force, if I want to resolve this tension in a direction going away from the angle given, like this. See, here's the angle given, this 20 degrees. If you want to resolve in a direction going away from the angle, I use sine. It's like you're finding the opposite side to it. So this is T times the sine of 20. And if I want to resolve the force in a direction which is going into the angle given, okay, like this direction here, going into the angle given, then I'll use cosine. So this is t times cosine 20. You can think of this is like the adjacent side. Okay, so this is going to be t times cosine 20. So if we're resolving the forces vertically, you have r plus t sine 20 is equal to 200 g, right? So that would basically be it. From here we can say that would mean that, okay, we'll just write it here, r is equal to 200 g minus t sine 20. Now I guess you could leave the answer like this if you wanted to, or you could find the actual values of these, but I would leave it like this for now. That's fine, okay? And that's what I would do. And then I would go on to find t by resolving the forces horizontally. Okay, now I'm going to do that, and then I'm going to try to resolve this dispute that the student is having. So let's resolve the forces horizontally. Now, horizontally, we know that there is an acceleration of 3 meters per second squared. Is it 3 or 0.3? Oh, 0.3, sorry. Okay, the acceleration is 0.3 meters per second squared. So this object is accelerating 0.3 meters per second squared in this direction according to our diagram. And we also know that the value of mu is 0.4. The coefficient of friction is 0.4. Okay, so now, with that in mind, if we resolve horizontally, we can say the resultant force is, you've got t plus t cosine 20. These are two separate forces. I'll just draw that slightly higher. You got t plus t cosine 20. Okay, those are the forces pulling the object in this direction. The tractor's pulling by the tractor. And that's not equal to that, minus the forces acting in the other direction, which is the friction, the maximum value of friction, F max. And that's equal to the mass times the acceleration, which is 200 times 0.3. Okay, and that's the resultant force equals mass times acceleration. That's using that. Okay, now we know that t plus t cosine 20 minus mu times r equals, that's going to be 60. All right. Now, what one of the students did was for their answer to part B, they used this equation. They rearranged this equation and made r the subject. So what they did is, and I'm going to do this here anyway, just to illustrate. What they did is they said, okay, they said that t plus t cosine 20 minus 60 equals mu r, and then they divided by mu. Okay, they divided by mu. All right, and that gave them, then the answer was like that. So it was r equals, now mu 0.4, so they basically multiplied both sides by 2.5, because 0.4 is 5 over 2. So they ended up with 2.5 t plus 2.5 cosine 20 minus 60 times 2.5. And that was their value of r in terms of t, right? So they're asking, how come my answer is not correct? Well, I would say that if you wrote your answer as r equals t plus t cosine 20 minus 60 divided by 0.4, that could be also considered correct in a way, although that's not how the question was intended. They intended to give you this little expression here and then have the horizontal components. I mean, the next step for us to do to solve this question is replace this r, okay, with all of this. When we replace the r with this, then we will have an equation that we can find t from, right? So that would be the next step. The next step is I'll take this r and replace it by this. Technically, this is r in terms of t, right? Even though the mark scheme doesn't mention this particular answer, okay, once we found what t is, I'm sure that this equation, if we found t correctly, this equation should give us also a correct answer. So I'm going to leave that over there, right? We're going to find what t is, okay, and then we will see if it's correct. But I think that should be acceptable as an answer as well, because it's r in terms of t. But it's not exactly what they intended. I mean, it's a bit of a long way of doing it. This is much easier, just resolving the forces vertically, which you would have to do anyway. So to answer part C, if you'd just done that and you didn't resolve the forces vertically after that, then you wouldn't be able to answer the question because there's two unknowns. So we have two equations with two unknowns. One equation is by resolving vertically, the other one by resolving horizontally. Both of them have r and t in them, and so we're solving these two equations basically simultaneously by some sort of elimination. So what I would do here next is I'll say, okay, t plus t cosine 20. Now I don't like to write decimal values for this until the end. Okay, minus, as you got 0.4, mu is 0.4 times r. What I'm going to do is I'm going to replace the r with this. Okay, so you got 200g minus t sine 20, and that's equal to 60. Right? So now we have to make t the subject of this. So I have t plus t cosine 20. Okay, minus, and 0.4 times 200, I think that's 80, right? That's 80g. Minus 0.4 times t sine 20 equals 60. All right. And now we want to make t the subject. So what I'll do is I'll add 80g to both sides. And I'll be left with t. And I have 1 plus cosine 20 minus 0.4 sine 20 equals 60 plus 80g. So t should be 60 plus 80g over 1 plus cosine 20 plus, that should be a plus here, by the way, don't make that mistake, minus 0.4 times minus t sine 20 is plus. Okay, so don't make that mistake. 0.4 times sine 20, and that should give me the correct value of t. Okay, so we put this in our calculator and we get the right answer, hopefully. So we're going to put a fraction, 60 plus 80 times, I think they use 9.8 in AQA, 9.8 for g over 1 plus cosine of 20 plus 0.4 sine of 20 equals 406.453, 406.453, and of course the convention is to round to 3SF, so 406 newtons. Okay, so I'm going to take this answer and I'm going to put it into this equation. Of course it should make it true because that's the same equation we basically used. But what I'll do is I'll just put the answer in here. So I'll just store this as A, and what I'll do is I'll say okay, recall A plus recall A times cosine 20 minus 60 over 0.4. Okay, so that should be the value of R. Okay, which if we use this, it should give us the same answer. Okay, so I'll store this as B, so we can keep it there. So we have 200 times 9.8, okay, minus, and I'll put recall A, times sine 20. That should give us the same answer that we just found. Yes, it does. All right. So basically, I mean, as we mentioned in the beginning, I would say to resolve this dispute that this is something that is doing the job of expressing R in terms of T. It's not what the examiner intended. They intended you to resolve vertically, but technically you are expressing the normal reaction force between the surface and the crate in terms of T. So I don't think it could be marked wrong. I think it would be unfair to mark it wrong, because even though you resolve the forces horizontally, there's a part of that involving R. Okay, there's a part of that involving R because of the frictional force. So you have expressed R in terms of T, and it's a correct equation, right? It does give us a correct value of R when you put the values of T in there, and it's R in terms of T. So I would say that it should be also accepted. Okay, although, this is actually what seems to be intended, as you see from the mark scheme. They don't mention this at all. They mention this, but I'm sure that if somebody did it in this way, it would be unfair for them to have lost the mark, because R in terms of T, that's exactly what's written. And you're going to have to do this anyway to answer part C. You'd have to have resolved both horizontally and vertically, right? So in general, in these type of questions, when you have, this kind of dynamics or even statics, you should always resolve in the direction that something is moving or something is, trying to move. If it's like statics and it's got friction, it's about to move or something, and also perpendicular to that. Whether it's on an inclined plane or horizontal, always resolve the forces in both directions, especially when there is friction involved. So in the direction of motion and perpendicular to the direction of motion, and doing that will help you to answer any question. If you do, you have to do both of them, especially when there's friction involved, for you to be able to answer the question. That's exactly what we had to do here. So I hope that was clear and it settled any disputes there. Thank you for watching. Other questions, if I ever answer any from the AQA board again, from this particular paper, you'll find them in the playlist that I will make and put up here. Questions from the topic of mechanics, M1. I'll add this to my playlist for Edexcel here and for Cambridge over here. You can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.